Okay, wait, I also need to load up my lecture code for today. There we go. Somebody on Piazza asked, like, how does Marty make his project compile so fast? And the answer is I compile it before class. You know, the first compile takes long. I just do the first compile before lecture starts, that's all. So a couple things, quick announcements before I begin material today. I think you all should know that by now that our midterm is a week from Thursday. That's not this week, it's next week on Thursday, right? From 7 to 9:30 p.m. I believe you filled out a form saying you know that already, so I'm just reminding you. I'm not really thinking that much about the midterm yet, and I don't expect you to be thinking that much about it either. But if you're one of those people who likes to start things early, I have posted some study materials you can look at whenever you like. There's a link at the top of the course website that says exams. I've posted some sample exercises and some topics and things like that. If you want to look at it, go ahead. I'm not going to discuss the exam yet until later this week or early next week, but it's there if you want to look. And if you have any questions, you can let us know. Let's see, what else? Another announcement I wanted to say was, last week we talked about recursive backtracking. We did a problem called the 8 queens problem, where we made it print out all the combinations of queens on chessboard. That code has been posted. I wanted to mention the code that we posted, the code that we wrote, was code that would find all of the possible solutions that were legal, and it would print them all out. And that's often what you want to do. Sometimes you don't want to find all the solutions. Sometimes you only want to find one solution and then stop. And you can do that by just making a small modification to the code that we wrote in class. If you want to see the version of the 8 queens problem that only finds one solution and stops, that's in the slides from Friday. If you go to that same part of the lecture, the version of the code shown there stops after one solution. I'm mentioning that because on your homework you have to solve a boggle game, and you're supposed to find a word, and then you're supposed to basically stop after that. You're not supposed to keep going every time. So it might be helpful to you to look at the difference between those two versions and use some of that in your code. It's a small fix, but you can take a look at it. So I'm actually moving on from recursion for a while, from recursion and backtracking for the moment. We just did 2 solid weeks on those topics. So, unfortunately, the bad news is that if I ask a question, you can't just shout out base case anymore. I mean, you can still do that, but it's less likely to be the right answer starting today. The unit of material that we're going into in general is going to be a couple of weeks in a row where we're going to talk about how to implement collections. So we have all these different collection libraries in our C++ library, like vector and stack and map and set and queue and all of these different things. And we've been using them, and hopefully you appreciate that they are useful for solving problems. Of course, somebody had to build those. What are they made of on the inside? So I want to teach you and talk about that in detail for the next several weeks. And we'll learn about several of the structures and how they're built. So today, I'm going to focus on how to build a stack, how to implement your own stack. And to do that, we're going to learn about arrays. We're also going to learn about classes, because all of these different collections are implemented as classes of objects. And so I want to talk about how you do that in C++. So that's the general plan for today. And then going later into the week, we're going to learn about something called linked lists and pointers, which you'll just love, trust me. It's a challenging topic, but I think we'll get there. We'll figure it out. So, okay, let me jump to my slides for today. So again, classes and building a collection, implementing a stack. All right, so first, I guess I talked about this. We've used collections. I want to see how collections are implemented. I don't want to dwell on that slide because I just said all those words, basically. So, collections are implemented as classes. So I want to do a quick, rapid review of classes, kind of what they are, how they work, what major components are put in a class, and how do you do that in C++. So, in general, I expect that you guys would know this mostly from 106A or the equivalent class, the equivalent course. But frankly, I've found that a lot of students are not very strong in this material coming to 106B. It's not your fault, it's just that you haven't practiced it a lot and it's hard to understand sometimes. So I'd review it a little bit. But I'd go faster than if I thought you'd never heard of any of this before. So ask questions if you need to. Classes are types of objects. So that's true in Java, that's true in Python, JavaScript, that's true in C++ as well. And the motivation for classes and objects is when you want to write a program where you have a new kind of entity that the language doesn't have a type for. C++ has strings and ints and doubles and chars and vectors and all these different types, but it doesn't really have a data type for representing a bank account or a calendar event or my joke is if you're programming a video game, like if you're making a Warcraft game, there's no orc data type. Maybe it's important to your program. Maybe you want there to be a data type called orc. So whatever, if you want to make a new type of data and put it into your program, you have to write a class. A class is a template for a new type of objects. What's an object? Well, you should know that, but an object is an entity that has data and behavior. So it stores some information, and it contains code that interacts with that information. When you write programs that mostly involve objects, that's called object-oriented programming. Java is an object-oriented programming language. JavaScript as well. C++ is technically object-oriented, but most C++ code that we've written so far has basically been procedural instead. One of the main benefits you get from writing classes and objects and doing object-oriented programming is something called abstraction, which is a separation from details and usage. So you can use a class without always knowing how it works. You guys have done this a lot in this course already. You use vectors, you use G windows and all these different graphical objects. And you didn't actually have to go read through the code of those objects to understand them. You could just use them. As long as you knew what the behavior was, the methods were, you could use them. That's kind of the main benefit of why we write classes of objects. Okay, so let's look at some of the components of how you do classes and objects. Inside of a class, you describe the stuff that every object of that type should have. You describe its data. The data inside of a class is called member variables. Sometimes called instance variables. That's what they might have called it in your 106A class. Sometimes called fields, etc. This is the data that every object will store. So like if you're making a class to represent calendar events, the data of each calendar event would be maybe what date it is, what time it is, the name of the event, who's invited to the event, information about that object. That's the data. That's the private member variables of the object. If you're keeping a class for an orc for your game, maybe that stores the location of the orc, the statistics about the orcs, weaponry and strength and all the different attributes that the orc has in the game. That's stored inside of that orc object. Okay, whatever. So an object is not just data; it's also behavior. The behavior is called member functions, sometimes just called methods in other languages. And the idea of these functions is that they are inside of an object. Not just some global function that you just call by writing the name of the function. You have to say the object name and then a dot and then the name of the function. And I know you know this because you've been doing it in all of your homework. When you call a vector and you say dot size, or call a map and you say dot put, you don't just say put, you say my map dot put, right? And so you guys understand this concept that like these methods are sort of inside of object, and you have to say what object you want to call the method on. And then the method interacts with the data of that particular object, right? If you got two maps and you call a method on one of the maps, it has nothing to do with the other map because they each have their own copy of this functionality. That's the methods of the class. Okay, so those are the two main things that go inside of an object. A class also has something in it called a constructor, which is a piece of code that initializes objects as they are being born or created. So whenever in Java, whenever you said this equals a new whatever, that was you constructing an object. You're executing a piece of code called a constructor. So I think those terms, should be mostly review, although you might have said, oh, I forgot some of that from 106A. But anyway, have you seen this stuff before? Does this sound mostly familiar to you guys? Your question sort of about the basic concepts here? No? Base case? Okay, whatever. So let's talk about a little bit about how C++ does this stuff. In C++, when you write a class, you typically separate the class into two pieces. It's a little bit weird. Most languages don't do this. C++ does. You write a file called a header file, which has an extension .h, and you write a C++ file with the extension .cpp. Basically, remember how we learned when you write functions, you can write those function prototypes with a semicolon? The H file contains prototypes with semicolons of all of the things that are going to be in your class. You declare everything, but you don't write all the bodies in the curly braces. That's what goes in the H file. In the CPP file, you actually write out all the bodies of all the methods. Why is it separated that way? Because usually a class is used by other parts of a program. A class is usually not a complete program. It's usually a module, a partial program, something that gets used by main or gets used by some other piece of your code. And so that other piece of code that wants to use your class usually includes your class inside of itself. And that inclusion includes the H file that has the prototypes that it needs. So, I mean, this is kind of just this detail of C++ that we have to live with. I'll show you how to do it. I don't think this is a good way to do things. I mean, Java doesn't do this. Python, JavaScript, they don't do this. But C++ does, and we must live in this language. So there's this kind of artificial separation. Let me show you what it looks like. This is what a .h file looks like. You have some hashed lines at the top and the bottom. The meaning of the lines on the top and the bottom are, it's technically called a preprocessor macro. It basically means that if more than one part of your program includes the same file, it won't declare it twice. It makes sure that your class only gets created once. It's kind of just magic mumbo jumbo syntax, but that's what it does. That's what it means. It makes it so that the same file being included 2 times won't break something. So in between those hash lines, you have the actual code, the actual class. You write the name of the class, you say class and then the name, and then in braces, you declare all the stuff that'll be in the class. You declare the constructors, you declare the methods, and you declare the variables. Now, you guys have probably seen these terms public and private before, right? That's slightly different syntax than Java or most other languages. In Java, if you want to say that something's public, you write the word public just on each individual element. This method is public void whatever, public int whatever. This other thing is private void. Each individual one you tag as being public or private. In C++, you just have sort of a public area and a private area, and you just declare many things in there. And all of them are that visibility, right? Now, what does public and private mean? Do you remember? What do those terms do in terms of the code's behavior or something? Yeah.
Public means they can be accessed outside the class, so like you call from outside, and private means that they're only contained within.
Yeah, that's a great answer. You said that public means outside of this class, other code can see these things, can call. If it's a public method, that means outside code is allowed to call that method. And private means that it can't, and so private is something that's inside, only for that class to keep track of for itself. So how do you know if something should be public or should be private? Like, how do should you just make everything public or everything private? Like, how do you make that choice? Yes?
If you need, you should be public only if you need another class to implement functionality from that class.
Okay, if it's meant to be used outside by other code, then you make it public. But if not, you should default to making something private. In particular, the data that's stored inside of the object is often private, and I want you to make data private when you write classes. You might remember people stressing that as being really important. Why is that so important? Like if a bank account object has the ID number and the name and the balance of the person as private data, who cares? Why do we care that that's private? You know what I mean? Like, what if my orc has a certain number of hit points, the hit point variable is private? Why do we make those private instead of public? It seems like maybe other code might want to look at those variables. So why don't we let them? Yes?
Like the code that you're referencing these functions in, or this class, you might make the variables the same name. So it's easy to reference the wrong variable.
Okay, so it could lead to bugs where the outside code is accidentally referring to the variables of the class. I think that is one reason. There's actually a lot of reasons why it's good to make things private. I'm fishing for some other reasons too. Do you also have another reason? Yeah.
So maybe if these other, like, you want to be able to see it, but you don't want them to be able to change it or anything, have like get or something where they can access it, but they don't actually have access to the variables, so they can't change it or modify it.
Yeah, that's right. That's an important reason why you want to make data private, because the outside code might try to mess with it in a way that we don't want. I used the example of a bank account with a balance. I picked that example for a reason because I don't necessarily want any random code to be able to reach in and change my balance of my bank account. That seems like that's personal to me, that's private to me. I want the bank or the bank account system to be able to manage balances. I don't want any random person to be able to manage balances. You probably wish you could manage your bank account balance and just do some plus plus on that shit, but you don't want random people messing with your balance. So I think you want your balance private too. So private is important. Some people have trouble extending these real-world analogies to code because they're like, well, fine, but code having access isn't like somebody reaching into my bank account or whatever. But it's really more like multiple programmers are collaborating and one of them accidentally messes up the variable the other one made. That's a lot like what you said in the sweater as well. Like, yeah, people messing up each other's data, you don't want to let other developers do that. So Okay, so those are some of the concepts and some of the ideas here. That's the general syntax. I'll show you an example. Here's me writing a bank account class. So I've got a class called bank account. The public methods are a constructor. It takes a name and a balance, a deposit and a withdraw method, and the private data is I'll store the user's name and balance. There's an important concept here which I hope is familiar to you, but I do see is tricky for some students to understand, which is what I sometimes call the instance concept or the replication concept. I hope that you either understand or else go become familiar with this concept, which means that like when you write a class and you see that there's two variables declared there, string name, double balance, that's not the same as other variables in like main. When you're in main and you declare an int, you get an int, you get one int. But this is more like a blueprint or a template. This is saying every bank account object has a string name inside of it. Every bank account object has a double balance inside of it. So this isn't declaring one string or one double. This is specifying a template. If you declare 10 bank accounts, you have 10 string names and you have 10 double balances. And so that's an important distinction. I think when I have seen students who don't totally understand classes and objects, my sense of it is that they just think all this code is kind of one thing that just happens once. But really, if you say bank account number 1, bank account number 2, bank account number 3, it kind of takes like 3 copies of all this code and smushes them into those 3 objects. And each of them has these variables, and each of them has these functions. And that's a big difference that's important to understand. If you don't totally get that, I suggest reading chapter 6 of the textbook. It's an important concept to understand. So, okay, that's the .h file. Now we have to write the bodies of the methods with the curly braces. I'll get to that in a second. But another part of using classes is that you have this code that talks to the class. We sometimes call that the client code. So here's an example of some code that uses our bank account class. It looks mostly like it would look in Java or something. Except I think in Java, most other languages, you would say like new bank account or something. You don't say that, but we've already seen that difference from vector and all those other types. So you declare bank account BA1. That is executing the constructor to initialize the object, the name and the balance. You can deposit money, maybe the balance goes up. You can make another account, you can withdraw. And so of course what happens is each account object has its own name and its own balance. That's what I was talking about before. Okay? So again, I'm reviewing right now, so if you're bored, that's okay. I'm trying to make sure everybody's on the same page, okay? Right? So that's client code. This would be like in main or something. Okay. So now, I mentioned this before that every object has its own copy of these variables and of these functions. So like if I say Marty.deposit, that changes the Marty object's balance. If I say Maron.withdraw, that will change Maron's balance. It's really important to understand that those are separate variables and they have different behavior depending which object you call it on. I think you know that because you had 2 vectors and you called this method on this vector and you knew that it wouldn't change that vector. But somehow when we're writing our own classes, it feels different. People lose scope or lose sight of things like this. So that's an important idea. When you're writing the code for these methods, you can refer to the data of the object that your code was called on. And we sometimes call that concept the implicit parameter. I'll show you that in a minute. I told you that we had the H file with the semicolons, and we have the CPP file that actually writes the bodies with the curly braces. So the syntax for that is you write a CPP file, you include your own H file so that your CPP code knows what the class is and so on. And then you write the bodies of the methods. The only difference between these bodies of methods and regular functions is that in front of the method's name, you write the class name with 2 colons. I think this looks really ugly. I'll show you. Do I have a slide for this? Here. Here's the implementation of the withdraw method. So you're saying, I'm going to write withdraw. It takes a double amount parameter, and it returns void. And now the code says if balance, whatever. And so when it says balance, it's referring to that private balance variable from before. But again, this kind of replication concept, it's referring to the balance of the object that you call the method on. So if you say Marty.deposit or withdraw, it'll set that object's balance. If you call it on Maron.withdraw, it'll set that object's balance. So the idea of like when I say balance, I talk about it like we use this in language as well, in spoken language. Like if I say I'm going to go home, you know that I mean my home. I don't have to say to y'all, hey everyone, after class, I'm going to go to Marty Stepp's home. Like, I don't even say that because you know if I just say home, I mean my home. Same thing for code. If I say, hey everyone, I'm going to reduce my balance, I'm going to reduce balance, you know that it means the balance of the object that the method was called on. So if I say Marty withdraw, it's that object. If I say Marion withdraw, it's that object, okay? That's why I think some students get a little confused because in the client code, this is like in main, right? You have a name of a variable or an object and you say dot withdraw and you have an amount. But then up there in the implementation of that method, it doesn't say Marty, it doesn't say Marion, it doesn't say any name of any object, right? It doesn't say Marty.balance, it doesn't say Marion.balance, it just says balance. The fact that you don't say what object it's called on is this sort of implicit notion that like it's whatever object you put here is the object whose balance gets changed, right? So again, I think of this as a review, but I notice a lot of students who are still coming to understand this concept here so far, right? Do you have questions about how methods work? I mean, a little of this is the syntax, but it's also the concepts underneath. So do you have questions about either of those things? Hey, in the back, what you got?
Why do we use the scope operator at top? I forgot how we typically use that.
Oh, the colon, why do we say that? Well, you're right that the colon is kind of called the scope resolution operator. Basically, I'm saying in the bank account class, this is the withdraw method. That's the meaning of that line. You're saying I'm writing a method that's void return, whose name is withdraw, it takes a double parameter, and it's inside of the bank account class. So bank account colon withdraw means withdraw method in bank account class.
And is it defined in our client as opposed to our header?
No, that is, so there's usually 3 files at minimum. There's your class with a .h file, like bankaccount.h. There's your class having a CPP file, which is like bankaccount.cpp. Both of those are implementing the bank account class and its methods. And then there's a third file, which is like main.cpp or wellsfargo.cpp or whatever. And that one calls these methods. It creates bank account objects in main, and it uses them and talks to them. I have, if you want to see, I have the Qt creator here. So it looks a little bit like this. Okay, so you have bankaccount.h. You write out some methods. You say, well, I've got a constructor. I've got some methods, deposit, withdraw. I've got variables. So this stuff is in bankaccount.h. In bankaccount.cpp, you write out the implementations of all these methods with bankaccount colon in front of them, one by one. And then the third file is you have some sort of client where you say, hey, make some bank account objects and use them. And you include bankaccount.h in order to do that. So those are the different pieces in play here. Yeah.
You have to write the bodies of the functions in the CPP files often. Like what we use maps or something, we use map.h, we don't need to write the constructor in our CPP files.
Oh, so the, well, wait, let me make sure I understand your question. You said when I'm using maps, I don't use the CPP file? What do you mean?
No, like, how come we have to write the body of the function in our CPP files? Although when we like use, in homework, if we like include something, we don't have to write the constructor and all the methods and the implementation ourselves.
Oh, well, so your question was when we use the existing types from the library like map or vector, we include the h, and now we don't have to write any of those bodies of the methods. Right, so I mean, I think the idea is whoever writes the h file also writes the bankaccount.cpp. Those two are like part of a whole. And then separately, somebody writes the main. Could be the same person, could be someone else later. So I guess when you include like map.h or vector.h or whatever, we already wrote both map.h and map.cpp, vector.h, vector.cpp. That's already packed into the library. So when you include those bodies are already written, they're already there. You can now use them by calling the methods, by creating a vector object, creating a map object, calling the methods on that object. So I'm showing, I guess the difference here is like, in that situation, somebody else wrote the class a long time ago, and now you get to use it, so you win. But like in this case, there is no class, but we decide we're going to write a bank program, and we think in the long run it would be helpful if there were a bank class. So we're willing to stop and take the time to write one so that the rest of our code can use it. So we stop, we write bankaccount.h, we write bankaccount.cpp, now we've got a class, now the rest of our code can go and talk to the class and use the class. But I guess my point is that the person who's writing the main method doesn't usually have to jump over and write the implementations of the class methods. Usually the class is written first, it precedes the client. Something like that, okay? Yeah, good question. Any other, I want us all to be on the same page and understand this stuff is important. So I want your questions. Yeah, go ahead.
How comes when you write on main, you clearly like you give the H
Oh, why do we only include the H file? We don't include the CPP file? That's a good question. I don't want to give you a complicated answer. I guess what I would say is when you compile C++ code, it takes all the CPP files and turns them into these binary files called .o. If you go to your build directory, you might see these files. All the .o binary files get mushed together into an executable file. That's what eventually can run. All the files are allowed to talk to each other and call functions of each other as long as they know the names of the functions that the other files have. So if this file has a function and the other file wants to call it, as long as the other file knows its name and its parameters, it can call it. And in order to know what those names and parameters are, it needs to include the H file to know that. Including the CPP file is not necessary because it doesn't need a copy of how the function works. All the functions get mushed together from O files into binary and it runs. I mean, I guess I'm just trying to say, like, it's more of a thing for the compiler so the compiler will know what class I'm talking about and what methods I'm talking about. But in terms of including the CPP, that gets done for you when the compiler mushes all these binary blobs together. So you kind of don't need to worry about that. Anyway, I don't think that's a perfect answer. If you want way too much detail about how files get compiled and mushed into binary executables, take CS107. You'll hear all about it, and you'll never want to hear about it ever again after that. Do you have other questions? Yeah, in the back.
How exactly do you use getters and setters to set the private examples
Right. That's a good question. So one thing, I forget if I have a slide on this. Let me double check real quick. Constructor. Okay, here, I do have a slide, I think, that answers your question. So we talked about how the variables inside the object can be private, so we don't mess with them, don't destroy their value or something. But if you make them private, what if you want to print out the user's balance on their receipt for them? Well, we usually write these methods called accessors, like you say get balance, which returns the balance. And that's basically a read-only access to that balance, because I think you know that it returns a copy of the value of the balance. My analogy is like when you go to the bank, you make a deposit, you can get that receipt printout, and you can ask them to write the balance on the receipt, the copy, right? If you take your receipt and scribble out the number and write in a different number, it doesn't like update your bank account, right? You change the copy. You didn't change the real thing. So that's what this is. Sometimes you supply a setter method called a mutator or modifier, where you let the client code change the data by calling a method. But some variables you don't want to have a set balance, for example, because that would let them change their money. You might let them change their name, like if they get married or if they change their name they want to be called or whatever, they can set their name. But you probably wouldn't have a setter if the variable needs to be constrained like the balance does. Deposit and withdraw are kind of like setters, but they're selective because you do if statements to make sure they don't deposit or withdraw the wrong amount of money. You had a question here?
Is there a way to like change access depending on the client? So like if you are Wells Fargo and you're using the program, you would want to be able to change the balance. But like if you're individual, you don't want to be able to.
Oh yeah, good question. He's asking, is there some way to get somewhere between public versus private where like not everyone can set the balance, but I don't want 0 people to be able to set it. Maybe privileged clients like Wells Fargo Bank or employees could set the balance. Yeah, Java, different languages handle that different ways. Java has something called protected access, where it's like private or protected or public, and protected is kind of in the middle. It's good for that. C++ has a keyword called friend, which I'll show you later. I'm not going to show you it today. But you can basically say that code right there, that's my dude right there. That code can touch whatever part of me it wants to touch, including my private parts. So, what? You don't do that with your friends? Come on. No friends with benefits and crap? I don't know. I thought young people were frisky. Anyway, yeah. But yeah, there's a way to do it. You can say this code is my friend, and it will allow that code in. I'll show you later, but not today. But there is a way to do it. Yeah. Google C++ friend keyword if you're curious. I wish there was like a frenemy keyword where they could use it, but then you would like throw an exception at them or something, or you'd talk bad about them behind their back later. Okay, so that's mostly the background I wanted to say about classes, just in terms of general concepts. Did I forget something? I might have forgotten Oh, I wanted to mention constructor for a second because I think a lot of students have a little bit of trouble understanding constructors. So constructor is a piece of code that runs when you create a new object. Like if you say, in Java, if you say bank account B equals a new bank account, that part where you say new bank account and the bank account gets born, gets created, that's where a constructor gets called. In C++, you don't say new, but the part where you declare a new bank account variable and you give it initial state, that's the part where a constructor gets called. Usually what the constructor does is it allows the main, the client code, to pass in some data, some variables, and it'll store those as the initial state of the object. So like, you don't want to have to do this. Make a new bank account, set the name, set the balance. That's annoying, it's tedious. It also doesn't work if the variables are private, so that's not good. What you want instead is you want to be able to say, well, make a new bank account, and the name is Marty, and the balance is this. So this line of code calls a constructor. Constructor is basically a method, but it has no return type, and its name is the class name. It's the bank account method when you can construct a new bank account. And so I take a string and a double and I store them into the fields, the private variables of the object. Whatever name, whatever balance you give me, I'll store them. And so I think I have a diagram like when you construct Marty, it calls that code and it stores the name and the balance into the two variable. I didn't write the values in, but it writes the values into those variable boxes to remember for later. Okay, so it's an initializer. Did you have another question? Yeah.
Sometimes there's ways to have multiple constructors instead of like default values, so you could just create an account called Marty and set it to 0. How would you do that?
Yeah, if you want a default or like multiple different constructors or different values, you can go here. I think I showed this syntax where you can say like equals and put a value and have a default, optional parameter. You can do that here too, or you can just write multiple constructors if you want, and then all of those different ways are allowed. So yeah, you can have more than one constructor if you want to do so. Okay, so that's mostly review, I hope, mixed with like how do you do it in C++. Okay, that's kind of where I'm at right now. What I want to do with this is I want to remember how we're supposed to talk about implementing collections. So this is why I want to learn about classes, is that collections are classes. So if I want to implement a collection, it means I have to write a class. And so the collection I want to write with you guys is I want to make a stack. Stack is usually implemented using an array. I haven't told you how to do arrays. I told you how to do vectors, but I don't want to use a vector because a vector is some library that somebody at Stanford wrote. I want to build this from scratch. So here's how to do an array in C++. This probably looks pretty similar to how you do it in Java if you came from Java. Not that different from JavaScript or other languages either. You write the data type that's going to be in the array, followed by a star, and then you give it a variable name, you give the array a name, and then you set it equal to a new whatever. It's an array of ints, you say new int, it's an array of strings, you say new string, and then in brackets you write how many elements, how many boxes should be in the array. Probably the only part of that syntax that looks weird to you is that asterisk. Why do you say int star? Well, that star is something called a pointer. I don't want to talk about that today. You don't need to worry about that until Wednesday. And then you need to worry about that a lot. So if you'll let me, I'll just say for today, that's how you make an array. Once you make the array, the syntax is just like what you did with vectors. You use the square brackets to get the elements out. So this little star thing, I don't think we have to like worry about the little star today. We can worry about it later. Okay? So give me that and I'll come back to it. Okay, so that's an example of me making seven ints in an array of homework grades. There's a couple different ways you can use an array. If you just declare it the way that I said, C++ does not set the values of the elements. In fact, they often have this weird gibberish numbers inside. And the reason for that is because it basically, when you make an array sits in the memory somewhere. C++ just like picks somewhere in the memory and goes, hey, right here, I'll make an array right here. And whatever bits were in that memory, it just leaves it how it was. So it might have been somebody's phone number, it might have been some images you were looking at on Facebook, it might be somebody's password, whatever. It's like, that's what's in the array now. Most languages, when you make an array, it wipes out the memory to 0 or something. If you want C++ to do that, you can do that by writing little parentheses when you construct the array. It's a subtle little bit of syntax. But the difference is that the parenthesis one is slightly slower So some people who really want the maximum speed, they don't do that or whatever. But so if you print this example, I mean, those values that I wrote there, I just made those up, but you'll get some kind of, if you run this on your computer, you'll get a different answer than your friend. You just get random gibberish inside the array. But if you do it this way with the parentheses, you'll get 0. So probably in my examples, I'll use the parentheses just because I don't like unpredictability. Yes?
Did you say there were differences between a dynamically cleared array and like an array with no star?
Oh, the one without a star? I'm cheating a little. There's two different, back on the last slide, there's actually 2 different ways to make an array. This first way is the way we're going to use. It's called a dynamically allocated array. Down here is what's called a stack allocated or fixed allocation array. The difference between the two is that if the array runs out of space, the one that I'm showing you will allow us to make it bigger. It's not trivial to do so, but we can. This other syntax will not. And so for building like a stack, we really need it to be flexible about its size. I'm not going to go quite yet into why that is or what's the deal with that. I promise I'll tell you. But for now, I'm just sort of not going to do the other style of making arrays. I'm going to do that. And at the time when you're ready, I will show you some of the other details here. It's tricky. Like, you know how we showed you vector at the start? We never did arrays back in week 1 or 2 or whatever. And I said, oh, arrays suck. You don't want arrays. Don't worry about arrays. Well, I have to do arrays now, and it does suck. There's weird details that I don't want to talk about. And some of this is kind of why we skipped it for a while. Anyway, that's how you make an array. You can access the elements using the familiar syntax. I will tell you, that is all you can do with an array. The brackets, accessing an element, that's it. If you try to print an array with cout, it doesn't print. It prints gibberish. If you try to ask for the length of the array, no, it doesn't have any variable that will tell you that. Tough, out of luck, doesn't know. The array doesn't know how big it is. Array has literally no features. It's just a brick of dirty-ass memory that the C++ compiler gives you. It doesn't even zero it out. It's got other people's trash in it, basically. An array is a big blob of garbage. So be careful. It doesn't have any features. But we need to base our stack. We're going to write a stack, and we're going to base it on array. So let's refresh. I've mentioned this very briefly in the past, but I'll tell you again. The way that a vector works, and the way that a lot of structures work, is that internally they have an array. So if you say I want a new vector, it makes an array of some length, like let's say 10 or something. And it's all zeros, nothing in it. And it remembers some extra stuff. It remembers how big the array is of 10, because arrays don't remember that for themselves. You have to keep track of that separately. And it keeps track of like a size, like how many things have you added to this vector? It's initially 0. And then when you add elements, it puts them into the first available slot, the first slot that has a 0 in it, okay? And so this is a vector that has 3 things in it. Now you might think, wait, I thought the vector kind of dynamically resized so it was exactly the right size to fit the data. Well, surprise, that's not really what it does. It keeps a little bit of extra space. And then if it runs out of space, it grows to a bigger array. And it does that because if it had to grow by 1 every single time you added an element, and if it had to shrink by 1 every single time you removed an element, that would be slow because arrays don't actually resize very easily in C++. If you want to make a bigger array, you have to actually make a whole new array and copy everybody over. That's really slow. So we don't actually want to do that every single time you add an element or every single time you remove an element. I think I might have said this back a few weeks ago, but I use the analogy of like a house. You know, if you buy a house that has a perfect number of rooms to fit you and your wife and your 1 kid or whatever, then when you have another kid, you have to sell the house and buy a new house. And you have another kid, you have to sell that house and buy another new house. That's kind of silly. So most people, if they can, they buy a house with a couple extra rooms. As their family grows, they have enough space, right? And then when their 10th kid comes, they call resize. And then they have room for the 11th and 12th kid and so on. But I don't know if my family's different than yours. Anyway, it's a little bit like that. So we call this idea an unfilled array. It's the idea that you might have extra slots. Now you might say, isn't that a problem? What if the user tries to go to these other slots? Well, the idea is that the array itself is private, so you can control the access to the array. You just don't let the client code look at those other slots, and then as far as they're concerned, it's as if they aren't there. And I know this is true because you never thought about this when you're using a vector, and so I know it worked on you, so I know this will work. Okay? So that's how a vector works. Vector is a little bit more time to implement. We don't have a ton of time. We got about 10 minutes. So I want to see if we can implement part of a stack. A stack uses the same idea, but it has fewer methods to write, so easier for us to work on. All I want to do is be able to create it and push data onto it and then pop data off of it. Usually the way we do it is we put the elements in from the left to the right, and as we pop, we go backward like that to the left. So that's the general idea. So I want to write a class called ArrayStack with those methods. Push, pop, peek is empty to string. So let's take a look. Let's go look at Qt Creator. So again, this comes back to our information about classes that we learned. So what you would do is you would start with an H file. You'd say, I want to write a new class named ArrayStack. And it has a constructor, and it has a push method, and it has a pop method, and it has a peek method. It has an isEmpty, it has toString. I guess I actually already wrote these variables in here, but I mean, we could, if I didn't have these here, like I guess the question would be, if I have to implement those methods, what variables, what data do I need? Well, the slide is intended to show the answer to this, which is, I want to store an array of data. This stack that we're going to write, I don't want to deal with storing everything, ints and strings and bank accounts. I just want to say, let's make it so it stores ints. That's easy for now. If you understand it for ints, we can make it work for other types later. So we basically need to store an array. But in addition to storing the array, since the array doesn't know how many elements it has, we have to remember that separately. We'll call that the capacity of the array. And then third of all, we have to remember how many elements they put onto the stack, because not all of the array might be full of data. And that's called the size. So we need the array, we need the size, and we need the capacity. Got it? And so that looks like this. Except the way to say array is star. Int star means int array. Okay? Question, yeah. Can you say again, please? What's the difference between size and capacity? Like in this picture, the size is 3, but the capacity is 10, because the user has made the vector and added 3 things to it. So in their view, this thing has 3 things in it. But in our internal view, it's got a total amount of rooms that we could fit 10 people in it. So it's a house with 3 humans and 7 empty bedrooms. That's the difference. Does that make sense? So, I mean, I've already got some of this H code here, so we can try to get done with this today. In the CPP file, I want to write all the implementations of these things. So let's talk about it. When you first, this is a constructor. When you construct a stack, I need to set the state of all the 3 variables. I need to set the state of the element array, set the size, and set the capacity. So what should those all be set to? The elements should be equal to something. The size should be equal to something, and the capacity should be equal to something. Help me out. What should I set those to? I mean, I basically want to match this picture, but I haven't added anything to the stack yet. Yeah? Size is 0 because initially they have not added anything to the stack yet. Great. Okay, what's the capacity? I guess 10 slots in this array. Okay. And then if we're going to say the capacity is 10, we have to actually make the array be that big, right? So this becomes a new int array of size 10. If we're being really good coders, we'll make a constant for that later. But that's the idea. Good. So now we've got an empty array. I'm going to put parentheses here just so it zeroes out those 10 elements. Good. Okay. So now we need to be able to push new data on top of the stack. So what's the algorithm here? Well, if you just look at the picture, imagine that it's all zeros and the size is 0. And they say they want to push 42. The 42 has to go in that first slot. And then we have to remember that. And then if they push a -5, that has to go in the second slot. So like, what's the general algorithm here? What slot do you want to put the new piece of data into? What index is it? I mean, you can even look at this picture for an example. If I were going to push another value like 99, here we go in. What's a general expression for the index to put the new value in? It's this equal to the size, right? Because the current elements are in 0 through size minus 1, so the new one should go in size. So that means elements bracket size equals n, the thing you want me to store. Is there anything else I should do? Like if I say push on 99 and I put it in the slot there, anything else I need to do? Yeah. I need to increase the size because now I don't have 3 elements, now I have 4 elements. That's exactly right. So I need to say, bless you, size plus plus. Good. Does that make sense? There is one thing I'm kind of missing. Yeah, go ahead. What if there's no space? What if I already have 10 and you're pushing an 11th one? Won't that crash or do something bad? Short answer, yes. I want to come back to that because that's a little tricky, but we absolutely need to think about that. So I'm going to write to do out of space question mark. I'm going to assume we have space for a minute. We can test it with small number of values for a minute. How about pop? How do you pop? Like if I go back here, assume I have these 3 elements. When I say pop, what I want is I want that top value, which is the 17. I want that one to be returned, but I also want that value to go out of the stack now, so it's gone. So how do I do all of that stuff? What's the index of the top value? Remember, the left is the bottom and the right is the top. So what's the general expression? Size minus 1, right? So int result equals elements bracket size minus 1. So get that last value out of there. And then I'm going to return them. That's what I'm going to return out. But I also have to scrub them out of the array, right? How do I do that? Maybe somebody I haven't called yet. How do I like get rid of that 17 so it's gone? Yeah.
Element size minus 1 equals 0.
Set that element to 0. Good. Is there anything else I should do? I'm popping this. I need to reduce the size, right? Because if the 17 goes away, my size will be 2 now, right? Yeah. So I'll say elements bracket size minus 1 equals 0. Zero it out, and then do size minus minus. Okay? What's peak? Well, peak is where you look at the element on top of the stack, but you don't delete it. That's pretty similar to this code, except you don't actually remove the guy, right? So the part where I remove it is this code. I don't want that part. So really it's just return, I guess I don't even need that variable. I can just say return elements bracket size minus 1, right? Are there any cases that I might be forgetting in pop and peak? Any places where the code might do the wrong thing? Yes? If size is 0, what does it do with the real stack, the library stack, if you try to pop it when there's a size of 0? What does it do in the actual library? Remember? No, it's not base case. It crashes. So I mean, you could, if you want to do this right, you could say something like if size is 0, error, sad face or whatever. You can say error. You could throw an exception or whatever. You can make it crash basically. Okay? Is empty. That just means size is 0. That's is empty. I'm running out of time, but the last method, I think that in order to see what we've built, I need toString. So toString should loop over the collection up to what index? Size minus 1 inclusive, not up to capacity, because those extra elements shouldn't be included in the toString, right? So something like this, string s equals empty for int I goes 0 through size, s plus equals, let's just do I'll just separate them with spaces. Elements I, just glue these together, and then return s plus bracket, something like that. Okay, let's see, if I included all the stuff I need, include error.h, and I think I include strlib to get those conversions to string. Let's try it. I think we can run this. The client is called stack client. Let's compile this and run this. Hey, that's us pushing elements. That's us popping elements all the way down until the thing is empty. So we mostly have a working stack. I know we rushed a little bit of that at the end. I'll post this on the website so that you can take a look. We'll pick up from here on Wednesday. Thanks.